Yeah, call me for the first one.
Calling you for the first one. I got it. All right. So the homework was page 2 of your reference table. I do apologize. I should have told you ahead of time that question 11 is not on there. I know some people Googled it if they really wanted a right answer. A bunch of people guessed, or some people skipped it. I apologize. I should have told you that yesterday. So now everything else should be found right on your reference table. Phoenix, what is the estimated time origin of Earth?
4.6 billion.
Yeah, did you memorize that or did you look on your reference table?
No,
Okay, that is okay for that one thing. A lot of people have that one thing memorized, but I don't like memorizing anything on these charts because please just check your reference table pages 8 and 9. Right here at the very bottom, it says estimated time origin of Earth and solar system. Nope, stay with me. And it's right there. So guys, one other thing I want to remind you, if it's under this black line of confusedness, you read these numbers. If it's above, you're going to be reading these numbers. So only the stuff in blue do you read over here. So estimated time origin of Earth, 4,600,000,000. Hey, Phoenix, you said something else though. What'd you say?
4.6 billion.
Did you write billion?
Yeah.
Okay, that's one thing I want to point out is you got to make sure your units are correct. So it's either 4.6 billion or you could write 4,600, but in that case, it's million.
How do they know that? Like, how do they know the Earth was made 4.6?
So we use this thing called radioactive dating, which we're going to learn about right after break. So they can take a rock and analyze what's in it and figure out how old it is based on that.
The oldest rock was 4.6 billion. What if there's rocks like?
That are older that we just haven't discovered.
Yeah.
Yeah, then there's that. That's why all of this, that's why science is always constantly evolving, and it's not that it changes, they just add more information.
What about? This is a better question that has.
Okay,
Keep
keep in mind, this is making it so you can't do more homework,
No.
just saying.
well, yeah, but what do you think happened to like make the Earth like, or just everything?
Yes, this is where it gets, so you're gonna ask me, and I don't really know. And it's not that I'm an idiot. This is what people are still working on. So you know, have you ever watched the movie, the TV show Big Bang Theory? With those scientists, you know what I'm talking about though?
Yeah.
So it's all those like really smart scientists. They work with Stephen Hawking, who has recently died, but he was a really smart scientist. That's the stuff they're working on. They're like literally still trying to figure out how and what happened and why. And could it happen again, or what's going to happen when it changes? That's what scientists are still working on. So I don't have an answer to you or for you, because not only do I not know, nobody knows for sure. They've got some ideas, but I got no, it's way above my understanding. Remy, what were you gonna ask?
So can you do carbon dating on like other things in space?
You can, except for it's not called carbon dating then, because then you need to have actual carbon. And there's some, we're gonna get to this after break, but there are other elements you can use, such as uranium or maybe the front page of my reference table. There's other ones on the front page of your reference table you could use as well. So the same, so how the moon is the same age as the Earth, they've discovered. Yep. All right, back to this. Name the 2 eons. Sam knows. Give it to me. Yep, here's 1 eon. Yeah, this one right here. Now, I'm not, you guys know me, I'm not a good speller. I don't mark off for spelling, or in this case, pronunciation, but I have a word of warning. See how many words are practically the same? We have this one that's Phanerozoic, this one that's Proterozoic, and this one that's Paleozoic. And there's other words that are very similar. So I don't care if you spell them right, but in this case, you have to make sure they don't spell a different word. So like when you're writing Phanerozoic, make sure it doesn't look like Proterozoic and it doesn't look like Paleozoic. So just to be careful, just go right to your reference table and slowly copy them down so you don't screw up. So notice how slow I'm writing and I still messed up. So just spell carefully. Don't try and do them from memory because they're all practically the same. So we've got Phanerozoic and Precambrian. So of those two, those are the two eons. Which one's the longer one? Anybody? Precambrian, that one right there. Notice, see how long it is? See how short it is? So that's the Precambrian. And they want to know how long it lasted. Do you guys know how to figure out how long something lasts? Like, how long is my class period? How would you figure it out? You got to subtract. If you know when class starts and when class stops, and you subtract, you'll figure out how long it is. So we can do the same thing with the Precambrian. And it does say, it's at approximately, so I'm good with estimating, or you could have done the true math. So here's when it started, 4,600,000,000 or 4,600 million. And here's where it stopped. You'll notice it's right between the 500 and the 600 line. By the way, do we know exactly when this line is? Yeah, follow that line down. 542. So to do this math, you would have taken 4,600 minus 542. And just because I just did this last period, sorry, 4,158 million years is how long the Precambrian lasted. Does anybody have something to say about that? That's how long one eon was. Any comments, notes, realizations? How close? Yeah, what do you want to say, Remy? Oh, thanks. Okay, so what I was getting at is look how close that is to how old the Earth is in general. The Precambrian is almost the entire age of the Earth. All right, next one. Name the 3 eras of the Phanerozoic. Allison, you get that one? Yeah. Mesozoic, Paleozoic. I'm not going to bother writing them. Hopefully you had them. So these 3 are the 3 eras of the Phanerozoic: Cenozoic, Mesozoic, Paleozoic. What are the 2 eras of the Precambrian? So here's the Precambrian. What are the eras that's broken up into? Landon, did you get that one? And if you can't say the words, just give me the letters they start with. A and P, yep. So these are the eons. I had asked you to do this labeling. That's an eon. And these are eras. So we've got, I think it's pronounced Arcanian. I'm not sure if I'm saying that right. And Proterozoic. So those are the 2 you should have there. Name the 3 periods of the Mesozoic. Sienna, did you find these ones? If not, go to your reference table and find the Mesozoic. Got letters for me at least? C, J, T. Cretaceous, Jurassic, and Triassic. Absolutely. How many millions of years ago was the beginning of the Mesozoic? So here's the yellow section for the Mesozoic. I need an exact year, millions of years ago for that one. Who wants to volunteer for that one? Go ahead, Trenton. How'd you know it was 251 and not 65.5? You're right, by the way. Okay, that's one way of thinking about it. The way I think of it is something has to begin more years ago than it ends. So we're going for the bigger number. This is the beginning. The beginning's always at the bottom of this reference table. The end is always near at the top. So this is the begin, that's the end. So the answer to number 8 was 251. So then when's the end of the Silurian? Everybody double check your math so I can call on anybody, even if you didn't do your homework. When was the end of the Silurian? And I just said math, there's no math. Just look at your reference table. End of the Silurian. Wait, no, Olivia's gonna do this one. So here's the Silurian. We want the end though. Yep. So this is where you gotta have to be really careful to double check what the question is asking. The beginnings at the bottom, the ends at the top, and question 9 asked for the end. So that is 416. Ooh, did anybody figure out what the divisions were based on? What? The whole thing. They're asking about all of this. Yeah, I got an idea.
I just in New York State.
No. Nice try. Thank you for volunteering. Let's look at the big units. Let's look at the eras. Especially the eras of the Phanerozoic. Let's look at the beginning of the Paleozoic. What's going on at the beginning? Great diversity of life forms with shelly parts. Now let's look at the end of that, which is also the beginning of the next one. Mass extinction of many land and marine organisms, including trilobites. The next one, mass extinction of dinosaurs, ammonoids, and many land plants. What is going on at every one of those changes? What? Yes. So how I describe it is it's major changes in life on Earth. So like he said, a bunch of births and then a bunch of deaths. So these eras are broken up into these major life events, kind of just like regular being a human. First there's birth, then there's the end of being like a baby when you start walking, and then there's end of being a toddler when you start like talking and thinking, and then there's the end of being a preschooler when you go to school. There's then there's elementary kids, then there's middle school kids, and then high school kids. They're all changed by major life events. Like you become an adult when you start doing adult things, and you become old when you retire, things like that. Yeah, so some of you might already be classified as adults in my mind. Yeah, that's not it. I wasn't, your name did not come to mind when I was thinking of that, but I don't know much about your personal life, so maybe. Number 12, what period is divided into the Pennsylvania and Mississippian? Pennsylvania, Mississippian, Carboniferous. And what is the most recent period? Now, when they say period, your answer better come from this column. Which one's the most recent? Yeah, it's at the top. I think it's pronounced quaternary, but again, could be saying that wrong. All right. Questions on reading the reference table? That assignment I gave you for tomorrow is all reference table stuff. Hardest part will be finding the words, but I promise you, it just keeps repeating, getting practice. Yes, you can work in groups tomorrow. Okay, let's get through today to see if we can get some things done for tomorrow. I kind of went back and forth on what I was going to do today, because I don't want to teach you something that you're then going to completely and utterly forget over break, and then I have to reteach it. So we're not going to do what I originally had planned, and we're going to actually fast forward to page 13. And we're going to not do overly too much today, I promise. So just like any time when I have a reading in our notes, if you check out the next page is where we're going to get some of the work we're going to do today. So originally this activity has Play-Doh that we're going to use. And yes, we're going to still do the Play-Doh stuff, but we're going to hold off and do the Play-Doh stuff after break. So we're going to, well, no, it's good because we're going to ease back into earth science by playing with Play-Doh on Monday after break.
We watch a movie.
No, let's keep going. So here's the directions. We're going to use the reading. Using the reading, we're going to write a description. So we're going to write a description from the reading. Then what we're going to do on Monday is we're going to make a drawing that shows this and use Play-Doh for the demonstration. And I'll do the okaying on Monday. So really all I'm asking you to do today is we're going to write the descriptions of these 1, 2, 3, 4, 5 earth science topics. And we're going to get the description from the reading. So you're going to be looking for in the reading a description of the principle of original horizontality, a description of the principle of superposition, a description of faulted strata, intrusion, and extrusion. But because I know that sometimes you don't actually read the reading when there's a reading, and just look for the words, I'm going to go ahead and read it, but you guys are welcome to highlight or underline those descriptions as I'm going along. So on that note, does anybody want a highlighter? Yes, I get the grouping thing. I mean, no, that's
What?
terrible.
Throw a rock at him.
No, just the highlighter. Anybody else? Phoenix, you want one? Oh, it's a good throw, bad catch.
No.
Anybody else? Sam? Ready? Nobody? No. Sorry, Alex. Oh, that was a great throw. Amazing catch. All right. So again, here's another thing. If it makes your life easier, you're welcome to gently rip the reading page off so you can have this right next to it. Do it gently so you don't destroy your packet. Again, you're looking for these words. You're going to highlight them in the reading. You ready? Principle of superposition and geological history. I like saying it like a superhero because it makes me feel cool. You ready? Sedimentary rocks are usually deposited in layers. In some places, the layers are tilted rather than horizontal. The principle of original horizontality states that no matter the present angle of orientation of the sedimentary layer, it was most certain that the layers were deposited horizontally and were tilted after deposition. Much of stratigraphy, the study of strata, which is rock layers, is based on something called the principle of superposition. That's a fancy name for when there are layers, the oldest layers are on bottom and the youngest layers are on top. However, the principle of superposition doesn't always apply. Wind, water, and glaciers can erode entire strata away and cause an unconformity, a buried erosional surface. And plate tectonic activity can break or fault, break means fault, uplift or tilt older strata above nearby younger strata. A good example of this is the Lewis Thrust, an area of Glacier National Park that extends from Alberta to Montana. There, 160-kilometer long and kilometer thick deposit of Paleozoic sediment lies on top of several strata that are hundreds of millions of years younger. Well, what happened? Originally, the strata looked pretty normal, but around 75 million years ago, tectonic activity along the Pacific coast of North America caused the land in western North America to be thrust upwards, creating the Rocky Mountains. In an area known as the Lewis Thrust, these forces uplifted a big slab of Paleozoic rock and slid it 80 kilometers eastward before it finally came to rest over a layer of much younger rock. Another exemption to the principle of superposition is an intrusion. An intrusion happens when hot magma squeezes into rocks and zones of weakness. The magma cools as it passes its heat energy to the nearby rock. This creates a zone of contact metamorphism around the entire intrusion. Because the magma is surrounded by pre-existing rock, the intrusion is younger than the rocks surrounding it. An extrusion is not an exception to the principle of superposition, but is an important concept to understand in the world of stratigraphy. An extrusion occurs at the surface. It is external. While the rocks below an extrusion is changed by contact metamorphism, there is no rock on top to be changed. Sometimes geologists find a layer of rock that has not changed the rock immediately above it. This is evidence that the layer above it was deposited after the lava cooled. Do you guys find the definitions for all 5? No. Which one are you missing?
Faulted strata.
Faulted strata, I agree with that. So in faulted strata, I'll tell you to go look for the word fault. And then separately look for the word strata, and I bet you can put them together. So take a minute, make sure you have the concepts highlighted. We'll go through them together, and that'll be all I wanted to get done for today in class. So double check that you have all 5. So what should I put down for the principle of original horizontality? I'll wait for everybody to get ready with me. Principle of original, oh, you guys are doing too much work. I only asked you to highlight them. We're gonna write them together. Would you highlight or underline for principle of original horizontality? Go ahead, Trent.
That all rock layers are horizontal.
And it specifically said sedimentary rock layers. So in this box, I would like you to pretty much write what he said. So sedimentary rock layers are deposited in horizontal layers. And then the second part of what he said is that they were tilted or faulted or folded afterwards. So I'm just going to sum that up and say any movement happened after deposition. So sedimentary rock layers are deposited in horizontal layers. Any movement happened after. How about principle of superposition, my favorite one? Somebody want to sum that one up? You got that, Drake? You want to sum it up?
Rock layers at the oldest at the bottom. This layer at the top.
Yep, I agree. So when there are layers, the oldest is on the bottom. And I'm going to add youngest on top. And that's a lot like if you think of a garbage can or your laundry hamper, the oldest garbage is always going to be found at the bottom of a garbage can. The newest garbage will always be found on the top of the garbage can. Did you guys end up finding faulted and strata? What does fault mean? Okay, that's so like a fault in a person, it means it's something that's not right with them. It's not wrong. You're not wrong. But let's talk about in earth science. It did say in the reading, plate tectonic activity can break parentheses fault. So what does fault mean? Just fault. Yep, just fault is break. Yep. And did you guys find the word strata? It's up at the top. Much of stratigraphy, which is the study of strata, the rock layers. So strata is rock layers. So what do you think faulted strata is? Broken rock layers. And just to add, what breaks rock layers? What did it say? What? Plate tectonics. About the arrow. Phoenix, what's an intrusion? You should have highlighted it in reading and gave you a highlighter. You have it highlighted, I see it.
Happens when, hot magma squeezes into cracks and so.
Hot magma squeezes in. Cracks. And zones of weakness. I have one question that wasn't in the readings. I'm gonna ask you guys, does intrusion sound like anything we've done already this year? Intrusive rocks. Intrusion is where intrusive igneous rocks come.
Crystals.
They grow really big. And where is an intrusive igneous rock? Inside. I want you to add that, inside. So this is gonna be inside Earth. Intrusion, intrusive, inside Earth. Now, extrusion, I'll give you, it didn't really explain what an extrusion was in the reading, but can we put the words together? Trenton had your hand up, what do you want with that one?
Where.
So magma makes it to Earth's surface and cools. I'm gonna leave it at that, but you're right, sediments can be deposited on top of it after it cools. But we're gonna keep that separate. One more thing, just like we did for the other one, add outside to an extrusion, because hopefully that reminds you of the word extrusion. All right, so like I said, that's all I wanted to get done for today. We're gonna grab Play-Doh on Monday after break, and we're going to demonstrate these with Play-Doh and hopefully have a little bit of fun playing with Play-Doh and learning at the same time. But you guys have a decent amount of time, especially since you already have a highlighter. Why don't you go ahead and start? If you can get through questions 1 through 8, you're done doing the highlighting stuff. So that first one says, on tomorrow's homework. So again, this is what you're doing in class tomorrow. So bring this back with you. So it says the division of time is based on major events such as mass extinction and explosions of life. The longest division of time is an eon. Highlight the word eon. So grab Phoenix, grab your reference table, grab tomorrow's assignment, and question 1 says to highlight the word eon. That's step number 1. Done. Number 2 says eons are divided into eras that are further divided into periods. Highlight the word era and period at the top of page 8. That's step 2. Number 3, finally, each period is divided into epochs. Highlight the word epoch. That's number 3. Wow, we're just whipping right through this. Number 4, this one looks long. Much of the rock record during the Precambrian has either been destroyed by some type of geological process, like weathering, erosion, rock cycle, crustal movement, or is buried too deep under the surface that it has not yet been found. Organisms from that time are believed to have been soft-bodied, and therefore the remains are not fossilized. So much of the evidence is missing. Oh, there was nothing to do there. Number 5, notice the Precambrian eon column of your reference table is subdivided into 2 eras. Eon divided into 2 eras. That's all you had to do was notice. We've done number 4 and number 5. Number 6, the Proterozoic and Archean are divided into 3 periods, the late, middle, and early. That's great. We just did it. Number 7, there are 2 places on the chart that have the age occurrence. It is located under the eon column and the epoch column. Highlight the millions of years ago under each location on the chart. Highlight millions of years ago, highlight millions of years ago. That's step 7. Number 8, look at the column for eon. What is the name of the eon on the top of the table? Here's eon. What is the first eon under there? Phanerozoic. Again, be careful with your spelling. Highlight the line at the bottom of the eon all the way to page 9. How long ago did this eon begin? So this is the line they're speaking of. Highlight that down all the way across. And funny, when you highlight it, you find a number. 552. What's that number telling us?
542.
Is what? When it began. Look at this. You're already done with questions 1 through 8.
Wait, I'm confused on them.
Number 10. Oh, especially since there's no number 9. Number 10, the section below this eon is divided into 3 columns of its own. This is because they have condensed the eon's information. What is the name that appears to the very left of this column? The name that appears on the very left in this column is an eon. What is the name of the eon? So they're talking about how this is really crammed in instead of being spread out. So we've got the eon, the era, and then the periods. They want the name of this eon, Precambrian. All they were looking for there. And when did the Precambrian begin? You find the Precambrian. Remember, they begin at the bottom. So 4,600. So I have already completed with you questions 1 through 10 tomorrow. I do expect you to finish this tomorrow. You still have a good 3 minutes. You can still keep plowing through. You can probably finish the first page. If you do not finish this tomorrow or you're not here, it is still due Monday after break. There's really no reason if you work hard tomorrow that you don't get this done. So it's not really homework because you're supposed to do it in class tomorrow. But if you don't, it is homework. I'm going to write that on the top of this. Maybe you guys should too, that this is due Monday, February, I think it's the 26th is when we come back. Yep. So whether you get it done in class tomorrow or you need to finish it up at home, it's due Monday after break.